All right, so this is going to be our Friday Valentine's Day lesson, but with sound this time. So this first slide I'm going to go through kind of quickly. It was just to remind ourselves of what find all solutions to the following problems on the interval looks like. So notice that there's no inverse notation here, which means that even though it's equal to a coordinate, so we'll give a radian value, that we don't have to have the restricted domain. So we're looking for any of the places where cosine is equal to 0 on the interval. So that gets us pi halves and 3 pi halves. Sine is root 2 at any of the pi fourth variations. However, it's positive, and sine is positive in the first two quadrants. So we have pi fourths and 3 pi fourths. And tangent is negative in quadrants 2 and 4, and at all of the pi fourths variations, it is equal to 1, because root 2 over root 2 equals 1. So that gives us a 3 pi fourths and a 7 pi fourths. So again, that's all you have to do for these type of problems, but it is the opposite to find a general formula for solutions to the following problems. So what we just did on this last slide is going to kind of be like step 1. So you're first just going to find where sine is equal to -1. On our unit circle, there's actually only one place that it is equal to -1. So it'll be 3 pi halves. So now to find a general formula, it's basically writing the rule to find every coterminal angle. So 7 pi halves is also equal to 3 pi halves. 11 pi halves, those could all be equal to, sine would be equal to -1, but it's all the variations of it. So we are going to use this first value right here, and we're going to add a 2k pi. And that's our answer. So again, this is that unit circle value that we have. And then this right here just says that every multiple of 2 pi, you will end up back at a place where sine is equal to -1. And that's because it only happens once on the unit circle. Cotangent is one of our sisters, but funnily enough, cotangent and tangent are equal to 1 at the same spots. So now we're looking for a positive, and so we have pi fourths and 5 pi fourths. So we are going to take pi fourths and 5 pi fourths. Now most of these problems will give you 2 answers. So when there's 2 answers, you have 2 ways of writing it. You can write it like this, and you'll write each individual angle separately, or in this case, we're going to try with 5 pi fourths and pi fourths. You will take, let's do this in blue. You'll take the bigger angle, 5 pi fourths, subtract off the smaller one, you get 4 pi fourths, which whenever you reduce it is pi. If the distance between these 2 angles is pi, then you have the ability to use this first pi fourths angle and simply write plus k pi. Since, again, so this happens twice. There's 2 places on the unit circle where cotangent is equal to 1. That distance between pi fourths and 5 pi fourths, if I draw a little bootleg, it's pi fourths and 5 pi fourths. So something I said last class, if it is directly diagonal from each other, the distance will be pi, and you will be able to write it like this. It will also mean that your distance is pi apart. So let's try that here with cosecant equals -2. Looking at our possible values, we have, that's really big. We have a √3/2. We have a 1/2. We have a 1, a 0, and a √2/2. If we had a 1/y, which is what cosecant is equal to, you wouldn't be able to use this because you would have the √2 still there. You wouldn't be able to use this because it would still have the √3. If you had 1/1, that would not get you a -2. 1/0 would not get you a -2. So we're looking at this right here, 1/2, but it's when sine is equal. We compare it to when sine is equal to -1/2. So again, you'll go to your unit circle. And where is sine -1/2? That's at 7 pi/6 and 11 pi/6. So now we're going to try that trick because we have two different angles. 11 pi minus a 7 pi/6. That gets us 4 pi/6. That is not pi. So our only option on this problem is to write them separately. So you'll write 7 pi/6 plus 2k pi, comma, 11 pi/6 plus 2k pi. And that's your answer. So you could have written this problem in the same way we just wrote this cosecant equals -2. However, it's more correct, I guess, if you wrote it the way that we did. But in this case, if we write out, again, our little bootleg unit circle, 7 pi/6 is here, 11 pi/6. You can tell that that is not a full pi. And then the distance here is going to be, if this is 2 pi/3, that's going to be 4 pi/3, which is not an even interval, so we're not able to write it in that new, fresh way. So these are your three options basically you have to choose from. If you only have one angle, you will only ever be able to write it exactly like this. If you have two angles and the distance between the two is pi, you can write it like this. And if you have two angles and the distance between the two is not pi, you have to write them separately. So, moving on to these next two, we will look for a spot where tangent is equal to -√3. So tangent is y/x. So we figure it's coming from a √3/1. And then using our unit circle values, we know that that's a √3/2 over, we'll just put a divide, over 1/2. So this is y and this is x. So where in our unit circle is tangent negative? In quadrants 2 and 4. So in quadrants 2 and 4, where do I have sine equaling √3/2 and cosine equaling 1/2, regardless of their signs? That is 2 pi/3 and 5 pi/3. So now we go and we see, do we have a distance of pi? 5 pi/3 minus a 2 pi/3 is 3 pi/3. That is pi. Hurrah! So we get to write it. Again, we use this first angle here, and we will write it 2 pi/3 plus 2, nope, not 2, plus k pi. And that's that. When our sisters are equal to 1, we take the sister function. So secant is the sister to cosine, which is x. 1 over x is equal to 1, which means our only option for x is that x is equal to 1. So where in our unit circle is cosine equal to 1? The only place that happens is 0/2 pi. However, whenever we write 0 plus 2k pi, the 2 pi gets included in that. So we don't even have to worry about including this 2 pi over here, because it is included in every iteration that we see on the unit circle. And it is not incorrect. In fact, it would be incorrect if you didn't include this 0. That is the most simplified version of this answer that we are able to possibly get. So keep in mind that this 0 must be there if your first place that this function is available at is 0. So again, that is finding the general formula. That's where you will write the 2k pi's or your k pi's. So, all right. Now, these type of problems that we've been working on, it's a trig function equal to a number, right? It's just right there. You have to do very little work. You go right to the unit circle and figure out where that is equal to that. When we don't just have those values popping right out of us, we have 3 options. We can factor, we can isolate the variable, and we can use our identities. On Wednesday, we'll be discussing where we would have to factor and use identities, but we're going to quickly go over isolating the variable. So we're going to isolate the variable on 0 to 2 pi. Again, notice that 0 has a hard bracket on it and 2 pi has a soft parentheses. So that means we include 0 and we do not include 2 pi. So with these type of problems, every time we'll kind of have an aside where u equals sine of 0. In math, we call this u substitution. It's when we see a problem that looks kind of easy, but then we get scared with the trig function. So we just turn the trig function, the scary part of the function, into a u. So that makes it so that we have a 2u plus root 3 equals 0. Now that's just a 2-step solve the variable type of equation. So that's very possible for us to do. So we have a 2u. You subtract your 3. Let me do this step by step. You subtract your 3 to the other side. And then you have a 2u equals a negative 3, negative root 3. And then you're going to divide your 2. And you're going to end up with a u equals negative root 3 over 2. So once your u equals something that you recognize, once it looks like something that we find on the unit circle, that's where you plug this sine value back in to here. So you will simply just add it back in when it doesn't look so scary anymore. So sine of theta equals negative root 3 over 2. So then this just looks like all those other problems. So we find on our unit circle, where does sine equal negative root 3 over 2? Since it doesn't tell us find the general formula, we'll just simply state where on that interval it is at, which for sine negative root 3 over 2 is 4 pi thirds and 5 pi thirds. So I had the class do this one on their own for a second. So take a second, pause the video, do this on your own, and I'm going to move on, but hopefully you took a second to pause, did it on your own. For this one, you almost don't even need the u sub, but it's just good to get it in the practice. You're going to say u equals cosine of theta. So then you have a u minus 1 equals 0. You're going to add your 1. So then you have u equals 1. You take your u, plug the cosine back in. So now you have a cosine of theta equals 1. And cosine equals 1 at 0 and 2 pi. However, that's why we have this up here. Remember, hard bracket on the 0 or inclusive, soft bracket on the 2 pi, so we don't include it. So our only answer here is 0. So even if it's the sisters, even if it was an inverse function, all of these are going to be about 1 or 2 step equations. Shouldn't be very hard at all. So that is what you do, and we'll be practicing that a little bit more as we go on. So that is one way to solve the trig equation, and then we're going to do the other ways next week. So happy belated Valentine's Day. Hopefully there's sound now. All right, cool.